Swayam Prabha. Digital India. Educated India.
Hello everyone. In the last lecture we have covered up to this advanced mates. Now in this lecture we will go about mechanical mates available in solid physics. In the mechanical mates we can see here the cam mate, slot mate, hinge, gear, rack and pinion, screw and universal joint. Out of these we have already covered hinge mate and gear mate. So now in this lecture we will start with this cam mate. So for this cam mate I have loaded some parts you can see here. So this particular part is called as cam. This is cam surface and this is a follower for this. So let us just assemble. We will fix this follower onto this . Now here we have this cam that is rotatable, that can be rotated along this shaft, and we have a follower that can move over here. These type of cams are generally used in piston cylinder engines, that is generally used to open valves. So in the cam mechanism we will go to mate, then mechanical mates. This cam follower asks the two things, that is cam path, that is supposed to be this surface, and the follower. For this follower the point that has to be lying over this cam path. Let us just select this center, we will click OK. So now we can see as we rotate this, you can see this follower is attached to the surface of this cam. So here helps this cam mate. So this was cam mate available in mechanical mates. So next one is this slot. So for that we will load some other geometry. Let us just remove these. I will insert component. Here I have this component with a smiley face kind of thing, and we'll make let's just make a copy of this. So this part has a slot into it. So this slot allows us to align the slot, the two slots or a slot or a pin to one another. Let's just check this. We'll go to mate, this mechanical mate, then this will select slot. So for this slot we need to make the two selections, that is slot and this slot. So this slot is now fixed over other. So let's fix this one, and you can see this moves as in line with the other slot. So just to make it better, we'll just attach both of these. So here you can see the slots of both of these are aligned to each other and they roll over other surface. We can also fix a pin into this. Let's just go to mate again. We'll select slot. We'll select two items, say this surface and this pin. So now you can see this pin is fixed into this, and this pin can also move onto the slot. This was slot mechanism. So the next mate available here is hinge mechanism that we have already covered. Now we will go about this gear mate. Let me load just some of the parts for gear mates. Here we have this gear and its housing. So let's just set up this housing first. I'll be a little quick while this assembly, please follow. So here we have this one spur gear rotating about this axle. So we need another of those. So I'll make a copy of these. And once again the same procedure. here we have two gear setup. I'll just make it floating. We can move over here. So what we intend to do is to align this rotation, and this will impact the rotation of the other one. For this we have to set up them in a plane. For that, so we'll select these two faces, we'll click on mate, and we'll align these as coincident. Click OK. So now both of these are in single plane. To make it as a constant distance, we want this to be fixed at a constant distance. So for this we'll go to show axis. So the axis of these two axles will mate. Now here it is coincide, so they will be coinciding with each other, but before that we have to select these, place them at an appropriate distance. So we'll align them very nicely. You can just take your time. We'll align in this way. So now again we'll coincide the center shaft, and here we have this offset. We'll click and it will automatically restore to its previous position and lock that. Now it is, we'll click on OK. We'll hide the axis. So here we have, we can see this moving because this shaft here is not fixed. So we need to fix it. Let's just place it well, and we will fix this shaft. So you can see this moving, and also this one. However, there is no relation as of now. So this relation is featured by this gear mate available in mechanical mates. We'll go to mate, mechanical mates. We'll just remove this selection, and in the gear mate we will select the two radius. Say this and this. So this gear mate automatically detects the ratio between these two. It has detected the ratio between the gear and the pinion, and as we click OK, it will link it up. So as we are moving this gear in a direction, it is automatically transferred over to the other one. So similar is the other case. However, in this case we can reverse this direction in case of maybe epicenter gears and others. However, we can reverse these directions. So we'll go to we can see here an option called reverse. So now check now. So both of these are moving in the same direction. So this is gear mate. So the next mate we will discuss about now is rack and pinion. For that I will be loading one geometry. Insert component. I will just load a rack and a pinion. Here we have this rack and this pinion over it. So this rack and pinion intends to as the motion of this pinion will translate this rack. These are generally used in conveyor belts. So let's just set up this rack and pinion. I'll just align these over one another. For this rack and pinion, I will go to this mechanical mate. Now, we will select rack and pinion. So, first this asks for this to select the rack length. So, for this rack, I will select the last edge of this rack, and for pinion, it is best to select the pitch diameter for this. However, we cannot see the pitch diameter as of now. To see that, we will do one thing. We'll just we'll go to the part details and we'll select this tooth cut. This tooth cut will make it show. So now we can see the tooth cut of this pinion. We'll align these. So now again we'll go to this rack and pinion mate. So now we again select this rack and this pitch diameter. I'll click OK. However, this can also move in other directions as well. So for this, we need to fix these axis. You can see this can move in upward direction. So to fix this, we need to lock this into this position. So for that, I will nicely align these two as we have done in this gear thing. So now we'll select the, we'll ask for to show the axis. We'll select this axis and base of this mate. We'll make it coincident and at a offset. So now as this pinion moves forward, you can see this rotating. If we lock this and we will move this rack, we can see this rotating. So now if we move this pinion, we can see this rotating. We can also reverse the direction like in gear assembly. So this was rack and pinion motion. So the next available mechanical mate is screw. The screw we have already covered. Now we will check this universal joint. However, this is not very frequently used in assemblies because there are many roundabouts for doing that. So let's just for just demonstration, we'll just check this. We'll go to universal joint, we'll import some parts. I'll just assemble these for setup. Click. So here we have this two shaft couplers. This is generally called universal joint. So what we require is to align the motion of this to transfer these to this particular shaft. For that, we will first of all align these nicely. Now I will go to mate, then the mechanical mate and to universal joint. We will select the two bodies, this and this. click OK. So now you can see as we rotate one of these, the other shaft is all coupled to it and moves in a nicely. So this is universal joints. So now we have finished all the mates available in mechanical mates. We have also covered this advanced and standard mates in previous lectures. So let's just revise these mechanical mates. We'll work around a simple assembly that will feature some of these popular mates. So we'll insert a example problem. So now we'll look for this so now in an example problem we'll look for the recently learned this mechanical mates available. So I have loaded this certain parts that would feature the mechanical mates that we have recently learned. So let's just try to assemble these as a demonstration. So here we have is a chassis, so that would mount all the racks. This is rack, a pinion, a bevel gear, shaft, cam and shaft. So we'll just quickly finish it up. We'll fix this rod here. We'll set up this bevel gear. Now the counterpart for this. I'm doing a little fast. You can please follow or slow down the video. To fix the pinion over here. Here we have finished this assembly. So, however, the mechanical motion part of these is not yet fixed. You can see each of the parts nicely moving, but they are not connected to each other. We have still got to fix this. So, for this as in gear assembly, we have got to align them well. I will fix this in this direction, say this. So now I'll lock this position. I'll select this face to mate as we did in this gear assembly, and we'll make an offset. Click OK. So now it is fixed to this. Similarly, in this we need this in rack also. So let's just fix the position of rack. And for this height, I'll select this edge and say this particular edge to coincide with an offset. I'll select coincide, offset. So now we'll align this mechanical mates. So we'll go to mate, then the mechanical mates. I'll go to gear first. I'll set up a relation between these two. So for first, this shaft has to translate the motion to this particular bevel gear. I'll select the edge of this inner shaft and the edge of this outer shaft. Click OK. So now on rotating this shaft, we can see the gear rotating. Now we'll make a relation between these two. Mate, again gear mate, select say this and the gear diameter this two. Just select this edge, just zoom it up, say this edge and the edge for this other bevel gear. Now it will automatically detect the ratio between these two and it is aligned. Now we can see as this lower bevel gear is rotating, it is aligned with other one. So now in the same way, I have got to align this to this gear with this shaft that is housing that. Mate, again we'll go to this gear. Okay. Now and this shaft has to be translated to go to gear, this select this shaft and the edge of this other. So you can see this as rotating and this is also rotating with this along the shaft. So now again we have to transmit this power to the upper gear. Now in the same way I'll go select this particular edge for this gear mate, select this edge and say this edge. You can see the teeth ratio, the diameter ratio is same for both of these. So as we move this, this is rotating. However, the rack is still to be fixed. So for this rack, I'll go to mate and we'll go to mechanical mates, then this rack and pinion. As you know, this asks for this rack edge length and this pinion. We'll select for now we'll select this approximately, and now you can see this moving. So we can see as this shaft is rotating, all of these parts are moving. However, the cam is still need to be fixed. So we'll quickly go to this cam mate. we will select this cam path and cam follower. For this cam follower, we need to select the vertex of this. So we will select this and click OK. So now this is also in rotating. However, this is not yet linked with this gear. So we again need a gear mate. Select this cam diameter to this shaft. Now it is well linked with the other gears. So now you can see this shaft transmits power to all of these particular parts using these mechanical mates. However, this handle is not yet fixed. So because we haven't transmitted power from this to this shaft, we can also do this. So once again we will go to this gear mate, mechanical mates, then gear mate. I will select, we will have to make this transparent to see the inner part. I will select click OK. So now it is aligned with the gear. So you can see as we rotate this handle, and we can see all of the parts moving using using the demonstrated mechanical mates available in this SolidWorks. So we have nicely demonstrated these mechanical mates. So with this this tutorial comes to end of the session, and so with this we have come to an end of this session, and we will wrap this up here only, and thank you very much and have a good day.